Guys, welcome to our new video tutorial series of operating system. In this video I will explain what is process and its significance in operating system. So a process is a program that is running on computer. It includes the program code and its current activity. When you open any application like web browser, game, or like Word or any you know a new software or new web browser, it will create a new process in your computer. So processes are important because they allow multiple programs to run at the same time on the computer. So like you can open the Word, you can open the web browser, you can also open the virtual machine, you can also open the multiple web browsers. Like I have my Mozilla for Firefox, I can open that one. I have Internet Explorer, I can open that one too. So irrespective of browser, irrespective of games, you can open anything, because it allow you can run multiple processes at the same time, without affecting the efficiency of you know the processes. So the operating system basically manages these processes, ensuring that they get equal resources they need. So you can see from the task manager, I already shown you multiple times in my previous video. So you can also see from there like the process, how much memory it take, how much CPU is consuming. So this is how it's actual work in Windows. You can also view on Linux. Like in Linux we have the command prompt. You can see from the running processes, and each process has their own PID, so you can also stop and you know delete that process and start that process again. So this management helps the computer run smoothly and efficiently. So or you already understand the process from my previous videos. If you are not, you must watch my previous videos. I have explained already briefly, and in this video I will explain more. So overview of process states in Windows and Linux. So every process states is different in different operating system. So in Windows, like we have these five states. First, the process starts new, like it assign a PID. Then the process is ready to run but is waiting for CPU time. So the process is currently being executed by CPU. The process is waiting for some event like input from user from a disk. So like if we run a process like a web browser or something, we just type something and search, and then it will run again. So the same with the any game or anything, you just log in with your account and then you start consuming the resources from your CPU. Then it will wait or block, and then the last state is the process has finished execution and has been stopped by the OS. So after the execution of that process, the process is terminated, and you have to, if you want to open another process, you have to open a new web browser or a game instance. It depends on you. It will assign a new PID for that process. So this is a straight diagram of a process in Windows. So first of all, we have a new state here which admitted in a system. Then it's ready. The process is ready for waiting for CPU time. Then after ready, it will go to the running state. And the running state, it will you know if the if we have the process takes like more time than a normal, like in Windows we have multiple processes running at the same time. So if the process is short, like it will not you know have no waiting time, or it will just go to the ready, then running, and then execute it. if we have multiple processes running in the computer same time. So in that case we will go to new ready, and after ready it will go to running, and then it will go to waiting, because we have a scheduler dispatcher. So what it do is, scheduler dispatcher basically schedule our processes in a way so every process can run simultaneously without affecting other processes. So like if we open a web browser, or if we open a hard game on our computer like PUBG or any big games that takes a lot of resources from CPU, and it takes a lot of time to loading, like maybe 2 to 3 minutes. So in that case, if we have a process like a web browser, it will go to ready running, and if we are like searching something, it will go to wait, and then again it will go to, if we search something, input from the input output operations, and then ready, and then it will go to the, again it will go to the running and then execute it. So also we have the interrupt. So if the process is in running state, we will interrupt that process. It will go to the ready, and then it will go to the running again and then exit. So we can interrupt that process as well by using the interruption in our, I will explain more about that. So like if we have a multiple processes run simultaneously, it will go to new ready running and then wait. And once like it will like allow maybe 10 seconds or maybe 10 milliseconds, then it will go to ready, then running, and then the new process added here, and it will go to new ready running and then wait. And once the wait complete, then the other process already in the running state will go to the waiting again. So this is how it our Windows manage these multiple processes simultaneously at the same time. Without the scheduler dispatcher, our process will not execute it. Because let's imagine if we have like two process, one process is searching on something on web browser, and one process is uh, opening a PUBG mobile game on your computer. So let's imagine if a PUBG mobile game take a 10 minutes time. So in that case, if it will go to new, if we do not have waiting time or dispatcher, it will go to running, and until it was running, all the resources and CPU resources, memory consuming by that process. So we are not able to open another program or another web browser or anything else. It will stuck. Or in that case, if the game is stuck by some error or anything, our our program is stuck by, if we do not have a scheduler dispatcher, because we cannot do anything until the program until the game start again and it executed simultaneously. Otherwise it will stuck here in a block state. So that's why we have a dispatcher that basically manage our processes so smoothly, so we have no idea how it fast otherwise. Yeah, if we have only one, no waiting time, it will stuck. We cannot do multiple processes at the same time. So the next thing is Linux process states. So how process states in Linux Ubuntu operating system. Okay, so new, the same with the Windows. The new process has been created, the ready, the process is ready to run but is waiting for CPU time again. The process is currently being executed by CPU. Then there is two different states in waiting. The process is waiting for some event. The state is divided into interruptible. The process can be interrupted by signals, example waiting for key press, and uninterruptible. So the process cannot be interrupted, example waiting for hardware conditions. So in Windows we have only interrupt, but here we have two different types of states, interruptible and uninterruptible. So the uninterruptible state is where it managed by the hardware, because there are some processes which cannot be interruptible because it's managed by hardware. So if you interrupt that, it will crash our program. So also we have the stop state and the zombie state. Zombie state, we will explain more about the zombie. The process has been stopped, usually by signal or by a user. Okay. And the zombie state has finished execution but still has entry in the process table to report to its parent table. So zombie state is basically a new thing in Linux, so it was not in Windows. So zombie state is a state where a process has been executed, like, but still exist in the process table, because every process has its own parent process. So it was just we have to there's a separate way to execute that zombie process. So understanding these states help in managing and optimizing how program runs on computer, ensuring that the resources are used efficiently. And so there's a state diagram for Linux. Already we have the new, running, and waiting. So in running process, we have six stop. This is a interruption from the you know signal from the user, so it will stop, and if we go sig count, it will again running, and then after running it will go to the exit. So if we running state, it was interruptible. It was like a sleep, and then it will wake up and then again go to the running state. And with the interruptible, it will again go to the interrupt state. Then there's a wake up signal, like user, after user added any input, then it will go to running, then six stop, when it will go to six stop, and then six count, and then after it will execute it, it will exit to the zombie state. So this is a, a different scenario in Linux. Like you seen in Windows, it was like simple, new, ready, running, interrupt, then wait, and then execute it, terminate it. But in Linux, we have like two different types of interrupts. One is uninterruptible and one is interruptible. The uninterruptible is basically the process is managed by hardware, so it cannot be interrupted. So uh, these processes are like our programs or our games or anything else, web browser. So we have these terms six stop, six on, which will I will explain in my next video. So stay tuned with us, and share, subscribe, and like our videos for more informative videos about uh, operating system. Thank you.